is the answer for number 9. And so what you're doing is you're doing AMA equals FR over FE, which is 14 to 1 is your AMA. 275 over FE, we're looking for FE. Cross, multiplied, and divide. All right, let's go to number 10 now. Number 10. Perfect. What we have is we have a ramp. We have a car, and we have a man that's pushing it. And he's trying to get to the gas station. So it says a driver runs out of gas at 1 mile, 5,280 feet from the gas station. Unfortunately, the gas station is at the top of the hill, which is 264 feet higher than the car at the bottom. The weight of the car is 2,800 pounds. What is the force will the driver need? So the first thing I want you to do is on your paper, write down the downward force of how much that car weighs, 2,800 pounds. Your FE is going to be this. Your DE is going to be here. And your DR equals 264. So what you're going to do is you're going to do your A squared plus B squared equals C squared. So my A squared is the weight, which is 5,280 squared, plus my DR is my B, which is 264 squared. That will equal my C squared. So to be able to get that, my DE equals 5286.6. And for that, the next thing that I have to do is I have to divide that. And once I divide it, my answer is C. Are you good so far? Okay, number 11. In a third class lever, the distance of the effort to the fulcrum is less than. The answer is A. Number 12. The simple machine that operates as a ramp that curves as a shaft is B, a screw. A. And 12 is B. Number 13 shows pulley system. So how many ropes do we have? How many pulleys do we have? We have how many? 5 pulleys? How many ropes?
No. 2. No, I don't know. That's a good question. It looks like 1, right?
It is 1. It's a 1 continuous rope. Okay? So it says if the pulley system shows a lift of 50 pounds and the minimum amount of effort force to apply for the system. So here we have this, and this has 50 pounds. So go ahead and draw it in there, put 50 pounds. So what we're doing here is we're doing IMA equals the number of strands. Okay? AMA equals FR over FE. So if we look, we're going to say, all right, we have 5 equals, that's AMA, 50 pounds over FE. So FE would equal 50 pounds over 5, which would equal 10. And the answer for number 13 is B. Write that down, please. Number 14 says, using the pulley image above, what is the distance do you need to pull the lift of the load 5 feet? So this is number 13. Number 14, we're doing INA equals DE over DR, which is 5 equals DE in 5 feet, because that's what they're telling it is. So the answer to that one is 25 feet. That is number 14. Everybody good? Okay. Number 15. 15 shows a ramp. There is a car there. That's 50 pounds. Saying we have that. 15 feet. We have an effort force of 20 pounds. And our height is 4 feet. It says calculate the efficiency of an inclined plane in this picture. So, IMA equals length times height, which is 15 feet over the lift, over 4 feet, which is equal to 3.75. Next thing we're going to do is AMA equals FR over FE, which is force resistance over force effort. That would be 50 pounds over 20 pounds, which would be 2.5. And the last thing that we need to do is we need to find the efficiency. So the efficiency equals AMA over IMA times 100%, which would be 2.5 over 3.75 times 100, which will equal 66.7%. And my answer is B. $16. Okay. Number 16, using an inclined plane of image above, make a ramp steeper would be decrease the mechanical advantage. Number 17. 17 says the force of a 50-pound is applied to a 1-foot diameter wheel. So we're using the picture there. So it turns 1/4 of an inch diameter of the axis. What is the mechanical advantage? IMA equals DE over DR. That would be 12 over 1/4, which will equals 4.8. Excuse me, 48. So where did I get 12 from? Yeah, 1 foot equals 12 inches, right? The next one, we have one wheel that's going that direction. We have a bigger wheel that's going in that direction. This is the driven out. This is the driven in. And N equals the number of teeth. So what we're doing is we're using the data chart that's there. So we have 12 is in, out we don't know. Diameter in is 6. The diameter out we don't know. The gear ratio is 3.17. WRPM, which is 1,800. WRPM out, we don't know. And then T in, which is 100, and T out, we don't know. So the first thing says solve for the number of teeth. So if we go, we take our number of teeth that we have, which is, well, first of all, our gear ratio, which is 3.17, equals the number out divided by our number in, which is 12. That's going to equal 3.17 times 12, which is 38.04. So the answer for 18 is A. So up here, I'm going to put 38. Where my question mark is. Number 19, solve for the diameter out based on the gear setup. So for number 19, I'm going to do 3.17 again, because that's my gear ratio. And then my angle out over 6. So that is going to be angle out equals 3.17.6, which is 19.02 inches. Excuse me, times 6, not 0.6. Sorry. We're going to do a couple more, okay? We're going to stop today. So for this one, 19.02, we're going to go ahead and put that in our data table also. Next one we're going to solve for is RPM. Number 20. So for RPM, we're still going to have our 3.17, except we're going to change our formula with what we know. So 3.17 equals 1,800 over, we're trying to find out what our RPM out is. And that's going to equal 1,800 divided by 3.17, which equals 567.82. And we're going to put it up here for our table. And the only thing we have left is torque out. So now it's asking us to solve for torque out based on the gear setup. So we have 3.17. Now we're doing torque out because that's what we've got. We're looking for torque out over our torque in, which is 100. That's going to equal 317, which is A. And that changes this one to 317. Now we have our whole data table filled. Excuse me? What was number 20, B? Number 22, when calculating gear ratio, which of the following is indirect relationship to the other? That is C, angle velocity. Number 23, we have a picture. We have A, our driver gear. We have our B gear, and we have a nested C gear. And we have a driven gear, which is D. So we have A, B, C, and D. So it says, the component gear train consists of 4 gears with teeth that are marked. So we have 10 teeth on our driver gear 1. Driver gear number B, we have 20. C, we have 5. And then on D, we have 40. A is a driven gear, and B and C share the same shaft. If A rotates once, how many times the rotation for D? So we're going to do gear ratio equals B over A times D over C. So what we're going to do is we're going to take the number of teeth that we have. So we have 20, 10 times 45, which will equal 16 over 1, which our answer is 16. So 23 is 16. And that is where we're going to stop there. On that.